Ahmedabad, the fastest growing city in India and the financial capital of Gujarat, has a population of more than 72 lakh. The city is known to be a business hub for its business fairs and trade events, and it is also a centralized station for tourists visiting Gujarat. Hence, the people visiting the city for frequent but short periods take the population count to a number higher than usual at all times. We all know that water is an essential resource for our survival, and Ahmedabad Municipal Corporation is committed to fulfilling the city's water requirement in the best possible way. Currently, AMC is supplying around 1,450 MLD treated water to Ahmedabad through its water treatment plants in Kotarpur, Raska and Jaspur daily. To ensure equitable distribution, the two most essential things are water data acquisition and central command control. Smart City Ahmedabad launched a central and command center for 148 water pumping stations, French wells and 3 water treatment plants in 2017-18. In 2018-19, the capacity was strengthened by implementing a control facility and adding 51 water pumping stations. AMC has now started work on Phase 3. This involves the addition of 30 more water pumping stations and laying few kilometers pipeline to distribute water to 7 zones of AMC. The residents of the various AMC zones raised a significant issue concerning low pressure and less quantity of water. To address this issue, it was important to gather the water source to water distribution data at the command plant and make it easily accessible to the higher authorities and the valveman operators in various zones wards. An agreement was made between SCADA, Smart City Ahmedabad Development Limited and Chetas Control Systems Private Limited in February 2020 to collect data on a pilot basis regarding the measurement of flow and water pressure from 655 strategic locations in 4 zones. Presently, 460 informative hydraulic devices has been set up in water distribution stations at strategic locations in the city. The key performance indicators that need to be shared on a common platform from water source to distribution are water flow rate, water volume, tank levels, pressure, energy consumption and pumping hours. Let's look at the results of integrating data on dashboard for analysis. The hydraulic data is now accessible to unlimited users at a time with the SCADA dashboard as compared to only 8 users earlier with SCADA. Past data for WTP, WTS and WDN locations is now available on common platform with the SCADA dashboard. Unlike earlier, it is now easy for a user to compare today's performance with yesterday's, along with balance time in hand to achieve last date performance. Observing and setting benchmarks will now help improve water distribution, as with the SCADA dashboard, information on how much water and at what pressure it is getting sourced at any particular location in the water distribution network will be available. This will help identify insufficiencies in water distribution, all the necessary key performance indicators that help identify non-compliance to performance of WDS for water supply with sufficient pressure at water distribution locations are implemented in the SCADA dashboard. These include inlet flow rate, outlet flow rate, outlet pressure, peak sump level, peak pressure distribution, last day WDS inlet quantity, last day WDS outlet quantity, total pumping hours in minutes, kWh and water versus energy. Predictive analysis is implemented for equitable water distribution at the WDS inlet in the new dashboard. It is now easier for the user to view data on a map to understand the geographical information. This dashboard has made it easy to identify the major non-complying WDS for water versus energy, for further scrutiny and for setting benchmarks. Also, customized water equation implementation is now possible with the SCADA dashboard. The new dashboard brought to notice the usage of approximately 100 mld groundwater that is, non-treated water mixed with treated water. It was also observed that more water was required to fill the sump, as an insufficient amount of water was coming through Water Distribution System (WDS) inlets. Another major observation was that approximate 300 plus bore wells were not integrated into the dashboard, which meant that a lot of untreated water was getting used. An approximate 70 mld unaccounted for water was highlighted by the dashboard, which could possibly be the reason for non-sufficient inlet water at WDS. As per the PO norms by the Government of India, distribution of 150 litres per capita per day (LPCD) has been suggested for metro cities. In comparison, the dashboards showed that water was getting distributed with an average of 170 LPCD, which is very high considering the population of 2021, even after adding an average growth rate of 2.54%. And this was excluding groundwater, which clearly pointed out that water was getting used more for commercial purposes than for the daily needs of the people, which made it necessary to lay administrative control of water. This was possible through the measurement of separate commercial and social connections to get the actual LPCD calculation. The matter was taken very seriously, as this imbalance was the reason for residents' water pressure and quantity complaints. With the information about the quantity and pressure of water at strategic locations in the water distribution network, AMC engineers, with the help of SCADA dashboard, are now fully equipped to give inputs to the valve men for an equitable distribution of water to the city.